future of Victorian infrastructure is green. Recycling Victoria has laid out a 10-year roadmap to a circular economy, a future where our state's public and private sectors will unite to prioritise sustainability. At the core of this are our public assets, the roads and railroads that connect us and ignite possibilities. But where does the change to green thinking begin? The Recycled First policy. Recycled First will require transport infrastructure projects to optimise the use of Victorian recycled and reused materials. This will see the use of recycled aggregates, glass, plastic, timber, steel, ballast, crushed brick, crumb rubber and reclaimed asphalt pavement take precedence over virgin materials. For information, technical advice and support on bringing your sustainable project innovations to life, drop ecologiQ a line. Recycled First, supporting purposely greener infrastructure.
So firstly, good morning everyone, and thank you for coming along to the ecologiQ Showcase. My name's Doyle and I'll be your host for today's event. And steering with me in the co-pilot seat is my colleague Lauren Rowett, who's an Industry Support Officer. So before we get started, although we're running this event virtually, I do want to acknowledge that we still meet on traditional lands. So to that end, I'd like to pay my respects to the elders past and present of the people of the Wurundjeri people of the Kulin Nations, which is where I'm seated, and also that we pay our respects to elders past, present and emerging, the Aboriginal and Torres Strait Islander peoples from every part of country from where you might be dialing in from. So the purpose of today is really all about presenting what's happening in industry to the audience, but also to our panelists. So to that end, I do want to welcome everyone officially. We have, you can probably see here, quite a number of people from representing the major projects. We have our panelists and guests from government, from industry, and certainly last but not least, we have our presenters. We're here to showcase their latest products and innovations for you for today's event. So just very quickly, for those who've never been to one of these events before, ecologiQ is a Victorian Government initiative to roll out the Recycle First policy. It is an Australian first, but it's very much about optimising recycled materials in a time where we're in the midst of a waste crisis and a great transition towards a circular economy, low carbon and sustainable construction. So there's a few areas in the ecologiQ team. We work a lot around technical standards and reform, around market development, which is what this event's all about, as well as working closely with the big build construction projects in Victoria to implement the policy in their procurement and planning. Now, we can only do this with the support of our stakeholders and our experts. So for today's event, we've assembled a couple of experts to help give some feedback to our industry partners. I might kick off with introducing Dimitri Polymenakos, who's a principal engineer with the Department of Transport. Dimi, did you want to say hello to the audience and maybe any thoughts on what you'd like to get out of today?
Yeah, good morning. My name is Dimitri Polymenakos. I'm the principal engineer structures. Yeah, I'm sort of in the innovative space as well, trying to work out how we can use different materials and at the same time try and make sure that whatever we do provides benefits to the community. So I'm looking forward to hearing what everyone's got to say and how we can make things work.
Fantastic. Thank you, Dimi. Yu Chin.
Hi, good morning, everyone, especially online attendee. My name is Yu Chin Gui. I'm a Senior Structural Engineering Advisor at Major Road Project Victoria and looking forward to use sustainability material in the road infrastructure.
Fantastic, Yu Chin. Thank you. And our own Shalini Trika, Technical Manager.
Hi, I'm Shalini, Technical Manager at ecologiQ. Just wanting to get a better understanding of, what the challenges and barriers are in using all these new recycled materials and how best we can support you.
Fantastic. Thanks, Shalini. So, look, this initiative is very much an example of what we're trying to do here at ecologiQ. You'll see there's quite a bit of call to action for you to reach out and engage with us because it is about collaborating. Because for us to succeed and see reform in this space, we do need to work with our stakeholders, our engineering partners, our design, and really importantly, our industry manufacturers as well. Because there's already a lot that you can do in the recycled materials front, but then there's also a lot of work that we can do in terms of pushing innovation and going beyond just the compliance. So Just a very quick run through of some of the previous presenters. So in the past, this showcase series has been running, that we were just talking earlier, about 1.5 years now. We've run 9 events. We've had eco bollards come into production through this platform. So these are 100% recycled and Australian made eco bollards. They're actually made by a social enterprise, so it creates employment for supported workers, which is a fantastic story. We've had recycled plastic conduits that have been type approved, trialled and brought into the market here in Victoria. So these are now approved for use in road projects as well as rail. We've had polymer concrete structures using recycled glass, and polymer concretes going into traffic islands and lane separators going into our projects, which you'll shortly see on the St Kilda Road project here in Melbourne. But the innovation journey is long, and there's still plenty more that, and I do offer this out to the audience. We've had green ceramics. So these are ceramics that can go into bathrooms, in pools, in your homes, in hospitals, in train stations. These are made by University of New South Wales. It's made using textiles and glass. So there's a great innovation, Australian invention, and still looking for opportunities on our projects. We have permeable pavement, made from end-of-life car tires. So it mitigates flash flooding, great for parking lots and shared user paths where you might want to promote your tree root health, growth, as well as obviously mitigate any sort of flash flooding. And options like Casafika, a business that provides a 100% waste-derived leveling coat, which can help smooth out shotcrete, fill gaps and cracks inside masonry bricks. It's made from polystyrene, glass, and paper. It meets Australian building standards, and the same material is used to make a masonry block alternative. And sometimes the most simple innovations are best. So DuraPanel Ortec makes compressed straw panels for soundproofing, as well as for soundproofing in sports stadiums and music stadiums. It's being used at sound studios at the Docklands. It's being used at the Sydney Olympic Games. So this is a great product that's available. That's also made right here in Victoria. And last but not least, last month we just had this great new innovation, carbon black recovered through end-of-life tires. So this is a lime replacement in asphalt. That they believe that it will improve performance, as well as extend the life, act like a sunscreen for the roads. And as part of that manufacturing of this, they actually come up with a tire-derived fuel oil, which is a diesel replacement as well. So this is a Queensland company that's looking to set up shop here in Victoria, and we'll be looking for sites to trial this on Victorian roads. But we're here today to talk about what's possible in concrete with recycled materials. I've got a couple of slides lifted from our visual guides, which if you haven't been in before, you should jump onto the ecologiQ Knowledge Hub and look them up. We know that when it comes to structural concrete, you can use supplementary cementitious materials to go into your concrete, but we know that we can also push the boundaries around that, going beyond 50%. We know that in non-structural applications like shared user paths, again, you can start using this CSMs, but you've also got options around geopolymer. And as we go through today, looking at what kind of different aggregates might be possible in that in terms of the innovative front. So you can use things like plastic fiber replacing steel. You can use things like crushed brick and rock, and you can use it in other applications like medians and curbs, as well as drainage pits and lids, which you'll see today. And head walls and wing walls, and again, geopolymer concrete right through to plastic applications. And so you'll see a theme of today, there's going to be a lot of talk about the alternative aggregates that can go into these sorts of structures. So now, event housekeeping. I'm going to keep to a strict time frame, but we have 4 presenters today, so a very busy lineup. You'll notice that although for the audience, you don't have video functionality, feel free to chat freely in the chat function. And if you do have any questions directed to our presenters are welcome to answer those questions at any time. I'll be moderating 4 20-minute presentations, 10 minutes to hear from our presenters, and 10 minutes to field questions from our panelists. So without further delay, I'll get Doug McLean and Michael Williams from GT Recycling to tell us all about what they're doing. Over to you, Doug.
Well, Michael kicked this one off, I think.
Don't worry, Michael,
No
over to you.
Yeah, good morning. Thanks, Doy, and greetings from Geelong, everyone. This is to introduce a recycled fibre as a strengthening factor in concrete. The significance of the photo there is that it combines all three of our collaborators in a trial site that we had in Geelong in July. So we've laid some number of pathways, and with Godfrey Hirst on site there with the support of Deakin University. So the fibre product that we're going to talk to you today is, but just back one, Doi, sorry, just got a little bit more. It's the result of a three-way collaboration. And Godfrey Hirst is a well-known carpet manufacturer. They're actually the largest designer, manufacturer and exporter of carpets in Australia. And in 2017, they had a turnover of about $430 million. The company is now owned by Mohawk Industries in the USA, but continues to run very efficiently and happily in Geelong and other sites in Victoria. Our other partner, Deakin University, is world-renowned in their expertise in fibre technology, especially located in their Institute for Frontier Materials at Warren Ponds and in the School of Engineering. So on the next slide, I'll pass to Doug for a bit of an overview and some background on GT Recycling.
Thanks, Mike. I'll just take the opportunity to give you a brief snapshot as to what our company GT Recycling is all about, and a little bit of the evolution of this particular project that we've entered into and the resultant product. So GT Recycling is a plastic recycler, mainly concentrating in the area of polyolefins, based in Geelong. The business has been operating for about 20 odd years, and it's it's not so much in the collection and recycling of curbside post-consumer waste. It's more in the area of industrial, commercial, and we do a lot of work with recovering waste plastic from councils, from tips, and also collection points that councils have around the state. We employ about 30 odd people, and we're currently going through a major expansion phase to go into the recycling of flexible plastic going forward. So we are, as you can imagine, as most plastic recyclers are, in an expansion phase. Look, this particular project and product evolved because one of our major customers in Geelong, Godfrey Hirst, was sending a lot of their carpet waste to landfill. We have the capacity in our business to recycle polypropylene carpet and also, to a point, nylon carpet. But a PE carpet has come onto the market for a range of characteristic reasons, and it's been a problematic waste to recycle in the past, and it's not only in Australia, but it's been a global issue for this type of product to be efficiently recycled into a sustainable, usable product. So we've been working in conjunction, as Mike mentioned, with our partners, Deakin University and Godfrey Hirst, to find a solution to recycling this particular waste. And we've come up with a product that we're quite excited about. We've initially called it a GT Fibrecrete 100 product, but it's a reinforcing fibre that will go into concrete. Non-structural areas to start off with, and we're talking about applications such as footpaths, driveways, hard stand areas in business, and cycle paths. It's quite a significant project, as I mentioned, because it's not only a waste product in Australia, but it's something that I think the industry has been grappling with globally, and we think we've got a pretty good solution at this end.
Sorry, Doug, I'll just note that you have 5 minutes left to present. So
okay, well I'll pass it over to Mike. I think that's enough, and Mike will give you a bit of technical detail on the product and a few more details. Thanks, Mike.
For sure. So just to leave no doubt about what we're talking about, there's some pictures there of some very familiar sites around the suburbs. Every local government authority in Australia has this issue that paths need to be replaced at times, and the GT Fibrecrete 100 can be used from the start, or it can be used as a retrofit for any of these cases. Next slide, Joy. Thanks. So on the left there, you can see the material as received from Godfrey Hirst. It's a mixture of colours and so forth, but that's fine. The middle photo shows the product as it then appears into concrete. And you'll notice, of course, it's very hard to see that the fibres are actually in there. They're not obvious, but they do have obvious characteristics. And the whole point is that concreters want a concrete that is still workable, and it's still going to provide the surface finish that they're after. So these are two key areas that we've actually been very successful in. We're expecting that in terms of capacity, there's about at least, let's say, 150 tonnes of this carpet waste per year as potential to be used. So in lab testing with Deakin across a number of years, you can see there the example of a standard concrete sample block without the fibres, and then the same stresses applied to a sample with the fibrecrete included. So there is a significant advantage to the product in preventing cracking in the start, but also then in reducing the propagation of cracks within concrete over time. We've complied with all of these different standards, and both the American and Australian standards there were referenced by Deakin as they tested and formulated the exact, I guess, benefit mix of fibres that we need to do. It's mentioned there that we've reached compressive strength of 25 megapascals, and actually on that's the most recent trial site at Godfrey Hirst, we were certified to 32 megapascals. So it's certainly been proven recently to be up to industry standards. Next slide there, Doy. So just to quickly work through the product life cycle summary, we do have at the start, of course, we use actually minimal energy to process the carpet offcuts into the fibres. The concrete projects can specify the GT Fibrecrete 100 for added durability. Through the production, there's no additional energy use over regular concrete, and there's no additional processes. Through the distribution, we're using the standard concrete trucks to mix and deliver the concrete to site. And importantly, for the usage and repair, our concreters have reported that it was no trouble for them to work with this product added into concrete. And over the time, it's proven to be more durable and require less repair. Actually, at GT Recycling site in Moolap, there's been a slab laid for a number of years, and it's very obvious to see this slab next to another slab that's run over by forklifts every day. But the fibre reinforced concrete is obviously very much together, and there's no cracks like the regular piece of concrete beside it. And then once concrete is decommissioned, it can be further recycled, and we're happy to suggest at this stage, it's only suggestion that perhaps it could be used as aggregate or road base.
I noticed it's the last minute, so we'll probably get to.
Yep, we can whip through summary of benefits. Once again, increased performance and crack control. We've reduced drying shrinkage as well with this product, and with all the workability and advantages of that, and it's very cost effective compared to virgin plastic fibres. This is a very high value, a low cost but high value product. And we were expecting that it would result in reduced injuries and public liability exposure for LGAs. It's a win for the environment, and it's expanding employment opportunities with a new product. Next steps, we're looking at a full life cycle analysis. We'll kick off in the new year. We're working with finalising the packaging, marketing, and gaining market acceptance through LGAs around our area. We would like assistance from anyone at ecologiQ or on the call with additional trial sites, and particularly to work with a concrete supplier that has operations in Geelong as a partner.
Fantastic. So I'll open it up to questions. Dimmy, do you want to kick off?
Yeah, Michael, I've got a question, and maybe it sort of helps with marketing the product. You make mention that this carpet product helps or replaces some steel mesh and concrete products.
No, actually, yeah, we're not actually saying that it can replace mesh at this point, but it does add durable strength to to concrete that's already reinforced. Yep.
Yeah, because all right, because the way I see it is the website does say that, and I was going through the website. My question was, if it does help you with reduction of mesh, then it will be a good idea to say, look, you know, for a footpath, if you guys are using SL62 at the moment, right, you can downsize to SL52.
Right.
And this is your cost savings. So your mesh costs, say, $100 a sheet. If you use our product, you can use another lower reinforcement. It only costs $70 a sheet. You know, so you're saving $30 a sheet. You're paying potentially a little bit more for the carbon fibre. You know, you're in front, and that way it gives the incentive, because industry these days is one, yes, we do want to use recycled material where possible, and secondly, we want to make sure that, you know, the price is really good, because, you know, builders and things go through a price. That was the first thing. The other thing also is to help you when you have footpaths and so on, you do have tension cracks and so on, and you want to use this material and recycle it. There may be opportunities to use this material on lower strength or compression concrete, where it's mainly using compression, which will then, you know, sort of give you some advantage that, you know, you can reduce, again, different things, keep it together, workability, Michael. But otherwise, it's pretty good. So you, in theory, you're looking for areas like concrete footpaths and so on. And I assume you've tackled the local council down at Geelong to talk to them, because they'll be doing a lot of footpath construction replacement.
Yeah, absolutely. And they've been tracking the development of this through. So we've got ongoing discussions with them. Yep.
Right. Okay.
Great. Thank you.
Thank you.
Thanks, Dimmy.
Shalini.
Hey, Michael, Doug, thanks for that presentation. Really interesting. I was more interested in the workability aspect. How does the fibre actually impact the workability of the concrete?
Our concreter was certainly very much tuned to watching out for how it turned out, and on site it was indistinguishable in terms of its pouring, the laying, and the smoothing across the top. So he was very happy to say that there was no drama at all, and on site it did need a little bit of extra water in each wheelbarrow load, but that's also, you know, that's one of the things that they deal with on a daily basis with any type of concrete they get delivered.
Cool. Thank you.
Thanks.
Thank you, Shalini. Eugene.
Thanks, Michael and Doug, for your presentation. Recycled material is my favorite topic. Just wonder, for the quality control process, how do you make sure that the recycled fiber from the waste carpet, you can make it like equivalent to the market synthetic fiber or plastic fiber?
Okay, that might be one for Doug from a production perspective.
The quality control possibly starts right at the source, and the carpet itself is new offcuts so it's quite predictable in its presentation. It's quality checked when it comes into our plant to make sure that it's got no other type of carpet mixed with it. And we have part of our manufacturing process incorporates specific pieces of equipment that allows us to give quite a standard product that meets that will meet the specification required to be added to concrete. So it goes through a range of quality control. Obviously, because it's a waste and it's a bulk waste, it's not precise, but it's within the specs that Deakin have felt would be appropriate for the application.
Yeah. So in terms of the tensile strength, have you looked into that aspect as well?
The tensile strength?
Yep.
Mike, are you?
Yeah, certainly. What we've got is that side-by-side comparison test with the concrete test block without the fibres, and using the same force, you can see that the concrete has held together. I don't have at my fingertips a quantified figure to give to you at this point, but we'd certainly be able to talk much more detail with people that will get in touch with us and have an interest perhaps in the product in more detail.
Thanks.
Fantastic, thank you. So I think some great advice, some great questions there from the panel. And you can see the call out from the team at GT Recycling, looking for trial sites, looking for concrete partners in the Geelong area to work with. So audience, if you can help out in any way, certainly feel free to reach out to Michael and Doug. Michael, Doug, I noticed there's a few questions that have popped up in the Q&A in the chat, so feel free to hop in there and answer questions from the audience.
Yep, no worries. I'll jump onto those.
Brilliant, thank you very much.
Thanks.
Thank you.
Pleasure. Now, up next, we have Mark Jackson from SVC Products. Mark, over to you.
Good morning, Doy. Morning, everybody. How are we? I'll just run quickly through this presentation as a bit of an introductory for those people who don't know SVC and what we're about, and then we'll just move into the circular economy of what we're working with at the moment. Next, thanks, Doy. So SVC is located down just south of the Moorabbin Airport. That's where our HO is and our main manufacturing plant. We've been located down there since the early 50s after relocating from Victoria Street in Brunswick. Next, thanks, Doy. So we're probably, we believe we're the country's second oldest precaster. We're certainly the oldest in Victoria. Been operating since 1948. Been involved in many of the landmark installations in Victoria, MCG in the early days, Federation Square, the Shrine. It's very difficult to move anywhere in Melbourne without probably 500-metre radius and not passing an SVC product. You won't know it, but it'll be there somewhere. We've been very involved in this state for a long time. The old wash troughs we used to make that your grandmother would have in a laundry, if you've had those there, they're probably an SVC product. So today we move on to where we are today. SVC is probably the most diverse, largest and diverse manufacturer of small element precast. Our civil division pretty much cover every council specification and road authority specification and electrical and other installations across Victoria and Australia. Our urban team produce some of the best and well-known architectural elements you'll see around Australia for urban architecture. And our Anston division is the architectural paving, commercial paving and other small elements in high demand for these very high-end projects. Next, thanks, Doy. In last year, 2021, we received our accreditation for ISO 9001. We've worked very hard on that over the years. Certainly, we spent a lot of money and time testing and retesting and being compliant with products. That's part of our mantra. We work very closely with specifications, with councils developing new products and so forth, and other areas. Thanks, Doy. So SVC's aim really is to be Australia's leading precast precaster in environmental and sustainability. Cement, as we know, is a very difficult product. It's high emissions associated with its production. We live in a world we have to have concrete. We can't do much about that. So our aim is to find that balance. This year we launched our sustainability charter, and this charter is pretty much embraced by everyone at SVC, certainly from the board to senior management to operations. Any of the areas that we can control to reduce our energy use and our CO2 emissions, we certainly will. And we have those same expectations on those who supply us as we work through our production. Thanks, Doy. So this year, we introduced to our factories at Mordialloc is solar. All the roofs of our factories are now covered in solar panels. We're completely off the grid. In fact, we probably put more back into the grid than we actually use. A lot of water used in concrete production. We harvest all the water we need for our requirements for production, and that's used in both the production of the material and the cleaning, washing, and then that's getting recycled. And any of the byproduct we have, damaged concrete, certainly all the steel molds that are beyond their use, packaging, whatever else is recycled back, and so is our polystyrene that we use for forming different forming elements, and that's all recycled as well. So this year, or in the last probably 18 months, we've been developing our own in-house. We batch a lot of our own concrete in-house, and we certainly buy a large volume of ready-mix concrete as well. But certainly for our in-house batching, we're using we've developed what we call an SVC Eco Concrete, and that's an eco blend cement we get from Independent Cement, which contains about, I think it's a 30% SMCs minimum. All the water we use is harvested on site. So as I mentioned earlier, and we've introduced into for all our small products at the moment is what we call the product called Polyrock. Now, Polyrock for our concrete SVC Eco Concrete replaces around 10% density of aggregate in our mixes, and we're currently averaging around about 300 kilos of Polyrock per day in our locally batched concrete. So according to Polyrock's data, that's sort of equivalent to 75,000 pieces of small plastics, and the Polyrock is manufactured from dirty plastic. So again, this is a great use and a great initiative by those guys, and it's working very well for us to introduce this into our on-site batching. We still use conventional steel reinforcement, but we've started adding the recycled e-mesh, recycled plastic macro-synthetic fibre. And what we've found, that's improving our early stripping or demolding of product. And certainly it's assisted with the handling of the green product, reduced cracking and spalling. I'm talking to the boys in production earlier this week, and our current mixed design has basically eliminated all the cracking and spalling. We still lose a few products with human error. That's to be expected, I guess. But the sort of the unintended consequence of us developing this new concrete or eco blend of concrete, we're actually making better and stronger products. When we talk about the ready mix or the pre-mixed concrete we buy in, we're currently sourcing that from Holcim, and that goes into all our precast pit production. That's the Vic Roads custom pits or the DOT custom pits, subdivision pits, and our commercial knockout range. So we use three different types of ready mix from Holcim's at the moment, and that's the EcoPact, Ultraflow, and Agilia. Further information, I'll leave that information. You can look that up on their website, but they are basically all concretes with varying levels of SCMs involved. So currently all our small element for municipal and other areas are made with our eco concrete. We're getting great results. As I said, we've reduced a lot of the shipping and spalling that were sometimes common, especially in the colder weather, which is difficult for any precasters making stuff in Melbourne in the middle of winter. That's where we have our challenges. We've submitted to DOT the data for their product range, and at this point, I suppose Dimmy will be able to talk about that. We've had no objections to that. Our plan would be to start all small elements right across our production range with the SVC Eco Concrete in 2023. So that's we're sort of limited at the moment by our ability to batch our own concrete. We've got a certain areas, but that will improve as we probably upgrade our plant in the future. But certainly we're using a lot of polyrock and recycled materials at the moment. I'm moving through this very quickly. I'm very pleased with this. If we move on to the next slide, please.
Great. I see you've got about 3 minutes, Mark. So
Yeah, no, this is the last one I want to speak about, so that's fine. So traditionally, through the specifications of the Department of Transport, or Vic Roads, as it was in the early days, we've been involved with the Department of Transport as it goes back from the days of the CRB, the Country Roads Board, the Road Construction Authority, Vic Roads. In 1992, the standards changed and the concrete covers changed for all pits in the stormwater for Vic Roads, and that was a concrete cover with a circular insert. Problem was always a very heavy product for the insert for maintenance crews. In the last couple of years, we've seen a transition over to lightweight load class C, SMC lightweight plastic products. Unfortunately, these particular products are a fully imported product. There is no Australian content whatsoever in these products. So what we've tried to develop, well, what we've developed now, excuse me, is a SVC Eco Concrete frame. This has been worked very diligently over the last 12 months to produce a product now that is a concrete section 125mm thick. That is load class C, so that's 150 kilonewton. And we've included an SMC insert. Now, the SMC insert is the lightest available for maintenance crews. This is 1/3 the weight of the traditional concrete cover, and it's about 2/3 the weight of the current offerings of the load class C fully imported products. The reinforcement's been reconfigured in this. The seating arrangement for this cover is a galvanised metal seat, which is integrated with the reinforcement, and the product we've got, as I say, we've tested it locally to AS3996 load class C, and we're absolutely delighted. So this product will enter production, we believe, well, it was going to be this week. We're just running a bit behind with our getting in reinforcement and the mould manufacturing, which is everyone's facing delays in the supply chain at the moment. But yeah, we're very excited about this product, and we'll hopefully see a lot of this product in DOT or MRVP jobs during the course of 2023. That's all I have. Thank you very much.
thank you, Mark. I might open with Shalini. Did you want to kick off?
Yeah, sure. Thanks, Mark. That was really enlightening, very, very interesting. Just wanting to understand, what are your current challenges and barriers in getting this across?
Certainly, we've been absolutely embraced by local government. The municipalities have jumped all over what we've tried to do. We've communicated very well, and we've created a new suite of products specifically for the councils, which has been embraced. And we're still working on other products, by the way, with that. One of the biggest challenges, funnily enough, we had was with the polyrock on a conveyor. So on windy days, the polyrock blows off the conveyor belt. So that conveyor has been covered over. So that was there was no major issues as far as developing the product. I guess the unintended consequences, we're actually producing in-house a better product than we had before. And that's been an upside. It wasn't intended. I mean, it was intended, but it was delightful to now that we're getting our goal of 40 MPa concrete is coming out at 45 on an average. So we're absolutely delighted with that. Less breakages, less cracking with our product, earlier handling. So it's been a win-win for us going down the path of the circular economy. So yeah, for us, there's no loss so far at all for us.
Okay, thank you.
Eugene.
Hi, Mark. Good to see you again.
Yeah, good day, you. How are you, mate?
I'm good. Very interesting presentation. Would like to understand a little bit more about the polyrock. In terms of long-term design life, what do you see about using the polyrock? Because so far haven't got the data or anything to support that aspect.
No, well, we don't foresee any problems. The testing data that we've done with the compression testing so far has been equivalent to the concrete or better than the concrete we've seen previously. Certainly the load capacity, we're not seeing any issues with that. We've put these things over machine and tested it. And the polyrock material itself is protected from degradation within the matrix of the concrete. So we can't see any downside long-term effects to that. We can only see improvement. I guess time will tell, but we can't, for all intents and purposes, we can't see this becoming any issue in the future. I think there is some testing that the polyrock guys have done themselves, and my understanding is they're actually seeing improvements in the concrete long term. So again, that's something that takes up directly with the polyrock guys, and I think they'd be embracing any discussions you'd like to have with them. You.
Yep, thanks. The other thing, what do you see like MLPV or DOT can support on your aspect, like your new product on that?
Yeah, certainly the larger volumes of concrete we use go into precast pit production. So currently our batching doesn't have the capacity to do that. We understand that the ready mix companies are trying to develop mixed designs using polyrock, and we'd be glad if they can. There are some logistical challenges to that at the moment. I believe it's not so much in developing the concrete, it's getting the polyrock into the trucks. And I think that's where the challenge is. So we would be hopeful that during the course of 2023 that the ready mix companies are able to produce the similar quality of the concrete that we're doing for the big roads or the DOT precast pits, for the subdivision pits, for the LGAs, and certainly for the commercial pits that we do. That's the biggest volume of where we use our concrete, but that's just a logistical issue at the moment that we can't put it into those products.
All right, thanks.
Thank you, Eugene. Timmy.
Yes. Hi, Mark.
G'day, Timmy.
From a DOT perspective, we are supporting and all of that, what you've just said, and I think we're actually, as you know, we're amending our pit specification to include that. You'll be happy to know that we're also working in the area of pit lids, because the pit lids that you mentioned that are coming from overseas, some of them don't comply. So we're actually cracking down on that. So that should actually help you with your business. In relation to the polyrock, I do understand that there is an issue of putting the polyrock into the concrete, but there's also an issue of removing it from the trucks that need to be washed. And that's also a problem, and contamination of the actual, the production concrete batching that takes place. But otherwise, fully support your product, and if we can make those other, the suppliers resolve some of those issues, we should be able to use more polyrock in the products.
It's very exciting, the fact that the polyrock is made from the dirty plastics, which is great to get that out of the environment. So we're delighted to use as much of it as we can. And certainly, our batch plant capabilities will improve as we move through the next 12 months. So hopefully we can introduce that into more products, but currently we are limited by our capacity.
Yeah, and if there's anything that you require from DOT to do more of, just let me know, and we'll try and make it happen for you, Mark.
Fantastic. Thanks, Timmy. Much appreciated.
No worries. Thank you.
Brilliant. Thank you, Mark. And really exciting to see that come out from SVC.
Thanks, Doy.
Thank you.
Thanks, guys.
No problem. So up next, Callum, over to you with Hanson.
Thank you. Can everyone hear me okay?
Loud and clear.
Excellent. So my name's Callum Wheeler. I'm the Offer Development Transformation Manager for Hanson. We also on the call today have Bruce Ryan, our Business Development Manager, and Brendan Liveris, our Sustainability Manager. Both will be able to answer your questions if you have any questions that pop up in the chat. Next slide, please. So today I'd like to focus our presentation around the replacing of virgin coarse aggregate with recycled concrete aggregates into the ready mix concrete. Next slide, please. So a little bit about Hanson. Hanson is a national business using world-class technologies and service platforms to supply a comprehensive range of high-quality concrete, aggregates and sand products. We're also producing road bases, asphalts and sustainable recycled materials through our Alex Fraser business down here in Victoria. We're backed by the Heidelberg Materials business, which is one of the world's largest building material companies, focused on developing materials to build our future. And at the centre of our action lies the responsibility for the environment. Our mission here is about leading change with our customers to build a sustainable future. So what is recycled concrete aggregates, or RCA? In its basic form, RCA is concrete aggregates produced using concrete construction demolition waste, which we're diverting from landfill. We reprocess this waste and apply specified standards to meet the requirements, which will allow us to replace virgin coarse aggregates in concrete production. So looking at the RCA, what about the properties? So just like traditional virgin materials, the product's available in a 20 mil and 14 mil graded aggregate. Unlike traditional aggregates, we see that the water absorption is quite a bit higher, sitting at around 5.5 to 6%. The shape of the material itself is comparable to virgin materials, and it is able to meet the minimum requirements for AS 2758. So that's the raw material. What about when we put it into the ready mixed concrete itself? What we found when we started doing the trials through here is that we found that it can shorten its open life or its plastic properties. At heightened replacement levels, it will lower the bleed properties of the mixers, and also likely to increase the variability of strength results. Also at higher replacement levels, we saw an impact on shrinkage results and ultimately some reductions there in compressive strengths by pushing those replacement levels so high. So what we found is that we recommend that it is a usable product, but it does have some limitations. So we think that it should be around the 32 MPa and below. There's plenty of applications that this product can be used in. And when we've taken it out to the field, we've looked at it at replacement levels between 10 and 100% of the coarse aggregates. And what we've found is the optimal replacement levels sit between around 30 and 50%. And that's to mitigate or eliminate the additional cement offsets. That's why we've come up with those. Next slide, please. So why should we use RCA in concrete production? Well, according to Sustainability Victoria, we've got availability of 6.5 million tonnes of construction and demolition waste within the Victorian market that we're using out of a possible 7.5 million tonnes. That's annually available to us. So by utilising this material, we're reducing our demand on virgin materials. And these virgin materials or reserves are depleting, and they are becoming harder to secure, and they're moving further from the developing areas. So each year we will utilise large volumes of virgin materials, and to replace them, we actually have to move out further and further from the developing markets. So where should we use this? So of the estimated 50 million tonnes of quarry products that are used each year throughout Melbourne, we only have access to about 5 million tonnes. So whilst there may be 7.5 million tonnes of demolition available to us, by the time we reprocess and clean up the material, that equates to about 5 million tonnes. So rough 10%. So recycled concrete as an aggregate is not a replacement. It's a supporting function there. So we need to look at targeting its use so that we're ensuring that we're using it in the most sustainable manner. So currently we utilise crushed concrete mainly in road base and fills and under slabs. So by progressing it into a recycled concrete aggregate for concrete production, we're looking at then expanding its usage into foot paves, curves, footings, blindings, temporary works, those types of applications. So while the RCA journey may just be beginning, Hanson Australia is well underway on our sustainability journey. So we're dedicated to producing at least 50% of our ready-mix products portfolio using a minimum 30% circular materials, which this falls into. We're also dedicated into transforming our portfolio so that we're generating at least 50% of our revenue through low carbon and circular products by 2030 as well. And you can see by the graph there, the uptake and usage of these types of products is significantly increasing month on month. And finally, so in summary, RCAs are a really valuable addition to virgin coarse aggregates, not a replacement, an addition. RCAs are a limited resource with limited availability in the Melbourne market. So we need to be selective about how we use this product to ensure we're using it in the most sustainable manner. The use of RCA aids in creating that circular economy that we're striving towards and minimises waste. And Hanson, as I said, is dedicated to producing over 50% of its ready-mix concrete using a minimum of 30% circular materials, such as this, by 2030. So I know that was a very high-level presentation on RCAs, but hopefully that has given you an oversight of recycled concrete aggregates in the production of ready-mix concrete. Thank you.
Thank you, Callum. I might open this on with Eugene.
Thanks, Callum, for your presentation. Very interesting. I always favor in the recycle, reuse in the infrastructure. The question for you, for this reconstruction material you do the recycle, how do you control that quality?
Thanks, you. Yes, so we apply specifications. We're fortunate that Vic Roads have set out some specifications, so they will be around grading specifications, contaminant content measurements. So we utilise on-site laboratories within our production facilities to carry out production-based testing on the raw materials that come in. And the production of those products. Very, very similarly to the production quality assurance programs applied to virgin materials.
Yeah, I understand that a number of the requirements can be met. For example, like VPB, normally like recycled material, the VPB is higher than required in the vigorous specification, like tensile strength and chemical content. How do you overcome this type of thing?
So this is right. We can overcome those through the utilisation of additional powder contents or specialised admixtures. The point and direction here is that this is not a replacement material. So the volume of available material can easily be used in applications where specifications such as VPV requirements are not needed. So targeting its usage in the right areas, such as curbs, such as shared footpaths, such as lower grade materials, will not mean that we have to put additional powder contents compromising the CO2 values of these mixes. So it's a balancing act there of utilising the circular materials in the right applications to ensure that they are a holistic, sustainable material, instead of pushing them across an entire portfolio where you're possibly compromising those overall sustainable values.
Yeah, very good. I think it's what you say is correct. Need to target the application, the right application, and this recycled aggregates still can be used in the infrastructure. Thank you.
Excellent. Thank you.
Fantastic. Demi, I might go to you next.
Yeah, thank you, Callum, for the presentation. There's a couple of things that I just want to ask questions and maybe sort of query a couple of things. You talked about it's not a replacement, it's actually an addition. That was one of a few times you've said that. And the other thing that you mentioned was there's a limited availability. Can I sort of, open up the sort of, the lateral thinking on this and ask a different type of question. You're targeting at the moment using this material in products that need to resist, say, megapascal strength. If we were to target your product, the recycled aggregate product, in areas that are not megapascals but are actually kilopascal requirements, and take, for example, beddings or putting it around drainage pipes, putting them in drainage filters, drainage beds, would it not be possible then to not call it an additional but a replacement product? So if I needed, say, 5 or 10 millimeter size aggregate, rather than buying your normal aggregate, buy this recycle aggregate, then putting it in those sort of applications, you're opening up the volume, which then you may not have the availability, but then you don't have to meet strict testing requirements of megapascal. Is that something you guys had a looked at? So not concentrate on concrete, but almost concentrating on replacing where typical aggregates being used in an area that's got less testing requirements.
Yeah, very much. Great question, Demetrius. And you're right. As far as recycled products go, Alex Fraser actually supply about 2 million tonne a year into the market, and it is very much focused around those applications. And yes, so we can utilise it very easily, and is heavily targeted towards the replacement of crushed rocks for road construction, for those filtration, or not so much filtration applications yet, but they are being used in a wide range of other applications. What we're talking about here is about as we start progressing it into all parts of the construction process. So this is about introducing it into the ready mix concrete production. As other alternate recycle or circular products can then fill in the space for these lower grade or different stresses. So you're spot on. We can use it, and we are using it in those applications at this stage. Where we've focused today is about how we're transitioning into the use for a recycled concrete application. And yes, we can use it as 100% replacement. We can do that right now. What we're identifying here, though, is what's the smartest way to minimise sustainable impact. If we go to 100% replacement, will we be effectively creating a new problem that we have to offset by putting additional powder in, which then introduces higher CO2 potentials as well? So that's where I focused on today.
Yeah, no, agree. I was just thinking, if you've got a limited supply and we are using all your supply in other applications in the road infrastructure, like road-based drainage and so on, that is still adding a value, which then means you don't have spare to actually use in concrete because it's all being utilised. And as long as we utilise all the available product, that's providing the benefits. That's where I was coming from. But you still got spare capacity after you've utilised your product on roads and drainage and blankets and etc. That's what you're saying.
Correct. It's about balancing that act so that every piece of demolition waste that comes in that is processed is utilised.
Right. Thank you.
Thanks, Demetrius.
All right.
Thank you, Demi. Shalini.
Thanks, Callum, for that excellent presentation. Just curious to know about the cost. How does the cost compare in comparison to the virgin aggregates?
So there are additional costs associated with the reprocessing of demolition waste, and they are very much a project by project orientated. It depends on location, plant availability as well. So there is no fixed, it will cost you X amount more. What I'd implore to the people on this call and for ecologiQ is to ensure that we have these discussions and we understand the offering availability on a project by project basis there.
Thank you. Thanks.
Fantastic. Thank you, Palmerston. Thank you, Callum and Hanson. Great to hear that, you know, some really strong targets that the business is working towards over the long term. So now for something a little bit different, I introduce Warren Rudd from Curvecrete. Warren, making concrete look fantastic. Tell us all about what you do.
That's the plan. Yeah. Hello, everyone. I'm Warren Rudd. I'm a co-founder of Curvecrete, and we are an advanced manufacturing startup that uses robotics to create low carbon bespoke curved concrete panels. So next slide there, please, dear. So for centuries, architects have always imagined creating beautifully curved forms like the Pantheon in Rome. Next slide there, please, dear. The Guggenheim and another one. Next slide there. And the Sydney Opera House, right? But these types of buildings, just one back, sorry. Yeah. So these types of buildings are very rare, and they're rare because they're very complicated and expensive to build. So what often happens is the bespoke design elements get value managed out of a project, and you're left with those standard structures that you see in the cities all around the world. Next slide, please, G. So not only are these designs pretty uninspiring, but their creation has a significant impact on our environment. Next. The production of traditional Portland cement accounts for almost 8% of the world's CO2 emissions. And, Australia's construction waste is a significant part of our country's waste stream. Next slide. So Curvecrete has a dual solution. So on the one hand, we have eliminated all the formwork waste in our forming casting process. And we also use byproducts in our low carbon concrete alternative. So in terms of the formwork challenge, so if you go to the next slide. So we've developed a robotic mold, and that mold allows us to create very bespoke curved concrete panels. We can do it simpler, quicker, and with zero waste. And that is just a clip of one of our earlier prototype machines. And we spent the last 3 years working on it, honing it, and improving the process. So just to get into a little bit more about the specifics around the technology underpinning the molds, we use a thing called ruled surface geometry. So it's rotating a straight line to create a hyperbolic paraboloid. There's numerous benefits for using this type of geometry in our applications. Number one, it means we can have straight edges along our panels, which allows us to butt the panels up against each other quite nicely. We could potentially also put rebar along those straight lines. And we can create double curvature panels, which makes the panels a lot stronger, and ultimately we could potentially use less material. Next slide, please. So this was just a slide. This type of geometry isn't new. It has been used before successfully in architectural projects. It was very popular with architects like Felix Candela and Anthony Gaudi. So next slide. And how this, in practice, how this really works with us is we've developed a technology that can take a curved design or a free-form design, and it panelizes it or divides it up into a series of panels. The technology then extracts the geometric coordinates of each of those panels, and it feeds it into our mold. We then cast that panel. Once it's cured, we deform it, take it off the panel, and then we repeat that process without creating any formwork waste. So that's kind of, that was really around the formwork, and then just talking about our low carbon concrete alternative. What we use a geopolymer. We've created our panels using a geopolymer. We have developed it in-house. We do not use any Portland cement in our mix. It's fly ash and slag, and then we use an alkali activator. And that really gives us properties that are pretty similar to traditional Portland cement for the applications that we're looking at. But the real benefit is it's up to an 80% reduction in CO2. We're using, and it has a positive waste footprint. So next slide. In terms of some of the challenges that we faced, so particularly around design, there are lots of, I'm sure everyone in this call will kind of be familiar with this, but there's lots of interrelationships between the various stakeholders. So typically what happens for us is a property developer will come up with an idea and they want to build something that's pretty unique. And they'll then engage an architect to come up with, who tries to capture that original design intent. But from then on, it gets a little bit trickier because each of the subsequent stakeholders try to value manage that project based on their own priorities. So, the engineers are very and rightly focused on risk. The builders are looking at cost and buildability, and the precasters are looking at the capabilities of manufacturing these very bespoke panels. And then in terms of the geopolymer mix challenges, so if you just go to the next slide, please, Jude, thanks. These are some of the common themes that we've encountered. First up, concrete alternatives not being specified within project documentation from the outset. When we start talking to people later on, the project started rolling, it's very difficult to then impact that material usage. Another one is there is a lack of industry experience using high content geopolymers. The industry tends to want to stick with what it knows and is comfortable with what it's used in previous projects. And then the third one is, there are some slight nuances to using geopolymers. So there might be a slight change, people might not be 100% used to working with alkali activators, for example, or there are some slight differences in the curing or casting processes. But the good news is that it's totally achievable. So we've actually just completed our first demonstrator project, and that is it's about a 35 panel. It's a curved staircase and emergency exit tower that is on a 15-story apartment building in the Melbourne CBD. So it starts off on level 14, it kind of goes through the roof slab and it finishes on level 15. Each of those panels are individually curved concrete panels that we made using one of our molds, so we generated no formwork waste, and each of those panels is a geopolymer panel. If you just go to the next slide. Previous slide. So some of the highlights from this project were, we achieved a pretty intricate design. When we first tabled it, people were kind of scratching their heads to work out how it was actually possible, but we achieved it. So pretty intricate design. We eliminated all the formwork waste, 100% reduction in the formwork waste in the casting process. We achieved an 80% reduction in the CO2 emissions using our geopolymer mix compared to a standard Portland cement mix. We were able to achieve a 13% reduction in the steel usage. You can see those ribs. It's just we were part of the design. We achieved a non-combustibility certification on the panels, and we achieved an engineering compliance and sign-off. So in terms of our production capabilities, we've set up a pilot manufacturing plant in Melbourne, which is on the western side of Melbourne, and we've built 5 production-ready machines which we're currently using. So at the moment, those 5 machines give us the ability to produce up to 10 square meters of bespoke curved concrete panels a day. But again, the really exciting thing about this is both the technology and the processes are scalable, and they're scalable very quickly. So we can scale this up depending on the size of the project or the project requirements. Some good kind of news from just to share with you. We've recently been awarded a gold in the Good Design Awards for 2022. And Manufacturers Monthly awarded us the Environmental Solution of the Year award. Next slide is really about the team. So we've got a pretty good team to deliver on this. Daniel's an architectural engineer, and he's a co-inventor of the technology. He's got deep industry knowledge. He's consulted to multidisciplinary engineering firms. I've got over a decade of commercial finance experience that I gained from working at large international manufacturing businesses in the UK and Australia. And we're also very lucky to have a very experienced advisory board. So if you just go to the next slide. We work with them very closely, and their skills range from structural engineering through to construction, project management, and rail infrastructure. And some of you on the call may recognize some of these faces. And then if we just go on to the next one. So really, we think there's a number of applications for this type of technology. On the smaller scale, it can be used for things like public installations. If you go next, we've got sculptural elements, and if you go next, it's landscape design. So that's all on the smaller scale. But on the much larger scale, which is where we are very excited and where we think we can have our technology can have a much bigger impact, is on high value design features on infrastructure projects. So things like cladding on train stations, bridges, substations, etc., shade structures for public areas, and noise barriers. And then the final, what we're looking for is we're looking for opportunities to trial our panels on your projects. We would love to be involved as early on in that as possible with your project, especially around the design phase, because there's a lot of value that we can bring around the shaping of our panels and some of the benefits that could help. We're looking to work with companies that are supportive of using low carbon concrete alternatives like geopolymers. And we're happy to work with you on smaller scale projects first, if that's a quicker pathway for us to start a relationship with yourselves. Yeah, that's it. Thank you.
Thank you, Warren. So open it up. Perhaps Shalini, did you want to kick off?
Yeah, thanks, Warren. Really good presentation. Just wondering, have you done any LCAs? Have any LCAs or anything of the likes been conducted for this technology?
Sorry, you broke up there. What was that?
Any LCAs?
LCAs?
As in life cycle analysis?
Ah, sorry, yeah. So we have, I don't have it with me, but unfortunately, Daniel, who's a technical co-founder, wasn't able to join the call, but yeah, look, it's very similar to traditional Portland cement applications, and there's no reason why we can't hit 50 years or even higher, but it's very, very similar. So just to point out, what we've started with here is non-structural, and that's really how we think we can get into the market and start getting our panels used, but the technology is totally applicable to structural as well.
Okay, great, thanks.
No worries.
Thanks, Warren. Timmy.
Yeah, good presentation, Warren. Very happy to see people trying to find better ways or cheaper ways to provide format for complicated shapes, because the more complicated the shape, the higher the cost to produce, and therefore builders, like you said, don't want to do that because they're cost driven. In terms of repeatability of the products that you produce, and one of the things, for example, in the road and bridge space, we do use of, you talked about claddings and so on. We come up with a very complicated panel that's going to look good today. If it happens to be damaged in, say, 3 years' time due to an accident, how hard is it to replace that panel? Because initially you may be asked, your company gets asked to produce 100 panels, 500 panels. Then we have an accident and we need 2 of those panels to be replaced. And if you don't use the same type, it doesn't look good aesthetically. How hard is it to produce more stuff that on work that you've already done, for example?
Yeah, very easy. I mean, all of them are driven by geometric coordinates. So as long as we have those geometric coordinates, which we do, because that's, every panel will have its specific coordinates. And yeah, it's very easy for us to do. Typically what we do is we number every panel, so we all know exactly which panel we've put where, and all the data behind that panel the production metrics, etc. So it's pretty easy for us to do.
Do you store that data somewhere in your database? Because in the road infrastructure, there's a lot of movement, a lot of change and refinement. So projects are being handed over to maintaining people or maintenance people. They may not have that particular code or curvature, but they do know, you know, for example, Curve Creek has actually produced a panel. If they came to you and said, you know, 3 years on, you know, Geelong Road, this beautiful feature was produced, would you be able to do that, or you don't store that data?
No, we would definitely store the data.
Okay.
Yeah, so we definitely have that data available.
All right. Well, that's a good thing. And then maybe myself and you, Chin, can talk to you or talk to us about it, an opportunity to use it on the major freeways that we're building.
Yeah, perfect. That's really where we think there's lots of applications and things like noise walls or you know, cladding to keep people engaged. You know, we can do textures on the panels themselves, not only curved. We can do different colors. So there's lots of opportunities there to kind of keep people engaged. You know, not the drivers, but yeah, other people.
Yeah, no worries. Thank you.
Thank you, Demi. Eugene.
Thanks, Warren. Very interesting presentation. I love that curve. It's very good looking. Just a couple questions for you. Before you do the casting for the concrete, do you do the structural analysis on that aspect, or you do a trial and error?
So we base it on a performance-based approach. So you know, there are a few I'm sure you're aware around the restrictions in the standards about SCMs that we can use. So typically we do we use a performance-based approach. But you know, I can tell you now, this research came out of the University of Melbourne initially, and we've worked quite extensively with Swinburne University, who we still have close contacts with, their digital construction lab, etc. And that's because, you know, Daniel is an architectural engineer and a lecturer at Swinburne, so we have access to all their testing equipment. We do you know, typical analysis and testing that normal concrete products would go through, and at the moment it's perfectly fine. We're getting, you know, about 40 MPa, and yeah, we don't see any complications around that.
Yeah, for this one, the curvature always come to the structural optimization. So you need to have a very complex structural analysis.
Yes.
I can see that is architect always like this type of architecture work, but come to the engineering always complex because you need to do the complex structural analysis and make sure everything is formed up in the right structure. And the other thing is like in terms of the how to say, opportunity you touch on using in the like in the noise wall bridges, this type of thing. How do you see, or have your team or colleagues see how they meet to the requirement in the infrastructure design requirement?
So I think I know what you're asking, but let me know if I'm wrong. But so from a noise wall perspective, we actually see it more as a structural application. And we are experimenting with a whole lot of things around, you know, post-tension cabling systems, where, you know, they can kind of all stack up a lot, self-supporting and stack up against each other and on top of each other. Is that kind of what you are?
Yeah, maybe this one we can take offline and discuss further, because it's more on the design, because what I see, this is more on the integral structure.
Yes.
So in terms of the integral structure, how are you going to meet to the design requirement?
Yes.
So this is the thing I more interested to know that. And the other thing is a geopolymer material. Just for your information, I think they got some limitation as well.
Yes.
Because for the ring strength development is very slow compared to the conventional concrete.
Yeah.
So that is my holding down that form of that structure as well, because some of this complex structure, you want to have the early development strength come in place, but it's not the geopolymer concrete or geopolymer material, the early strength development is quite slow development.
So we actually heat cure ours, and we get very within 7 days we get a very high strength product through that heat curing process. So yeah, but very love to kind of talk to you more about it. If you were keen to come and visit the pilot factory, we could show you around. So yeah, we're very keen to kind of keep talking.
Very good. Thanks.
Thank you.
Fantastic. Thank you, Warren. And thank you to all our presenters and panelists for today's showcase. So again, I said at the start, all of our activities, at the very least, it's been educational and entertaining, but it is still a call to action. So if you've been interested or intrigued by any of this, please get in touch. So we do have a knowledge share. We've got our website. You've made it here to the showcase. Next year, we'll be running more of these events. We actually run them bi-monthly around a different topic and a different theme. If any of you out there are keen to connect with businesses like the ones that presented here today, come along to our exchange. So we do organize online networking, and next year in person. And if you made it to our conference earlier, so in September, we'll likely have another conference next year as well. And outside of this, we do have ongoing lunch and learn sessions. They're actually all uploaded on YouTube and on our Knowledge Hub. So if you do want to learn more about a particular topic, please get involved, and you can just drop us a line at ecologic@roadprojects.vic.gov.au. I just want to talk very quickly about our Knowledge Hub, because a lot of questions that are directed at us are actually, the answers are on our Knowledge Hub. So if you're a government, you're part of state or local government or federal government, you're a part of a construction contracted construction project, or a technical advisor, you can request access to our Knowledge Hub. We have a tremendous amount of resources there, a supply map to help you find businesses like the ones that presented today. We've got reference guides where we've done the homework for you and actually rounded up all the standards and specifications that permit for you to use recycled materials. We've got a visual guide, which I whipped through earlier, just talking about what can already be done in terms of different applications on construction projects. Tons of education awareness, the lunch and learns, the YouTube videos, master classes around particular topics. So it's a treasure trove of resources. We encourage you to get involved in that. And if you want to be part of the technical reform and change, Shalini here leads our technical reform program. So we do a lot of work with DOT, with Metro Trains and other asset owners to look at undertaking trials and reviewing standards and specifications, as well as working with our university partners and other research partners into new and emerging materials. So again, this is a call to action for the audience. If you do want to get involved, please reach out to us, because we understand, and I think we all know, and we're all here today because we know that we're part of a bigger change process. So if you want to get in contact with any of our presenters today, here are their contact details. I've recorded today's presentation. We'll send this out as an attachment to everyone who registered for the event. So again, we encourage you to reach out to our presenters today. We heard from GT Recycling. They're looking for a concrete partner in Geelong. They're looking for an opportunity to trial. SVC Products are about to launch their products that include polyrock and other recycled materials in them. Hansen has made a huge commitment to circular materials in their concrete offerings. And last but not least, Warren from Curvecrete, looking to partner with architects and designs for our projects, because if you do want to see wonderful, beautiful outcomes on your projects, then you can design them in from the start. So any other last words from our panelists? Otherwise, I'll bring this to a close. No worries. Thank you everyone for joining today's Innovation Showcase. Yeah, we'll be taking a break over the Christmas holidays, and we'll see you again in the new year. Thanks for coming along.
Thank you.
That's all.
Thank you.
Thanks. See ya.
Thanks.